Good morning, good afternoon, and good evening, guys, based on the time zones you all are coming from. So, my name is Neeraj Kedia, and I have been working in this IT industry for more than 12 years now. All right, so the main agenda for today's session is we are going to discuss on the components of DevOps, one having a complete understanding of what exactly DevOps is. Then we are going to discuss on Azure DevOps, components of Azure DevOps, that means what are the services available for Azure DevOps that we are going to discuss for multiple use cases. Like for example, here we are going to discuss on Azure Boards, Repos, pipelines, test plans, and artifacts as a part of Azure components that we are going to see step by step as we move further with the course. And then we are going to discuss on Azure pipelines, as in how we can design the pipeline, just like we have Jenkins in the conventional DevOps lifecycle. Same way we have pipelines through which we can design the entire flow of the application. So first of all, let's have a quick introduction to Azure. So Microsoft Azure is a growing collection of integrated cloud services which developers and IT professionals are using it to build, deploy, and manage applications through global network of data centers. So Microsoft Azure, as you know, is the second large, we can say the second most popular platform for cloud computing. The first one is AWS as an Amazon Web Services offered by Amazon itself. Then we have Microsoft. So AWS has currently a market share of around 34%. Then followed by Microsoft Azure having a market share of around 19%, 19 to 20%. Then we have GCP having a market share of around 12%. And then followed by other vendors like we have from IBM, VMware, DigitalOcean, we have from Alibaba as well. So these different vendors are containing almost, we can say they make up almost 10 to 12% of the complete market so far. So Azure is one of the most popular servers where currently Azure has 100 plus services in different categories. For example, we have services for computation, Azure for computation, then we have for storage, for databases, for analytics, for security, custom networking, for AR, VR, for machine learning. So there are multiple group of services that is all offered by Azure. And Azure is currently deployed on 54 plus regions for increasing the fault tolerance of the application. And currently it is active in 140 plus countries as well. And Forbes, again, they mentioned Microsoft beats Amazon in 12-month cloud revenue. So Microsoft was able to generate $26.7 billion to $23.4 billion. And then IBM came third with the third. We can say that the third vendor having the highest amount of revenue being generated. And here the table that we can see towards right, it is about worldwide public cloud services revenue forecast. That means by 2021, the cloud business process services is going to be almost $56 billion, whereas cloud application infrastructure is going to be $27 billion, then followed by cloud application services on a SaaS base to be $13, and then cloud management and security services to be around 16%. And the system infrastructure services that is going to be charged at 63 billion USD. All right. Now, next is Azure has multiple components. Like Azure has on-demand provisioning. When we say on-demand provisioning, that means we can deploy the resources exactly at whenever we need, and then we are also have the option of paying as you consume. That means okay, we are going to address that query towards the end. So pay as we consume, that means if we have deployed 50 different servers and that too for 10 hours, that means we have to pay only for using those 50 servers and that too for a duration of 10 hours. And we also have to pay on the configuration of servers that we have deployed. Suppose if we have deployed a memory optimized, computation optimized, or storage optimized, again, we can choose what kind of servers we want to deploy and for how much time we are going to use those services, and then we'll be looking at the services being deployed accordingly. And then here we can focus on abstract resources. That means we can focus only on a requirement and we can start deploying it exactly as per the need. That means we can choose the services that we are looking for that we can deploy. For example, suppose if we have a requirement of deploying a multi-tier architecture, then we can take the help of multiple services, and we don't have to focus additional services which we are not going to use. We can limit ourselves to the resources that is meant for us, and through that we don't end up having more expensive than what we have planned for. And then it is measurable. That means we can create our own custom dashboard where we can measure everything. That means we can have an analytical platform. We can keep a track of the billing component as well for almost everything that we have to do on top of this platform. Next, we are going to discuss on Azure. So Azure, as you know, is basically a complete cloud computing vendor where we can choose what kind of services we have to deploy, where we can use the entire setup for the physical infrastructure that has already been set up, and then we can choose accordingly, as in what kind of components we need in terms of setting up this entire infrastructure. For example, we are going to use only storage services, only computation services, only networking services. We can choose accordingly depending upon the usage type. And then we can deploy the services, then we can define the storage types, each and every component one by one, exactly by what we require. Now, in terms of services category, we have multiple services available, like we have for computation, migration, security and compliances, for storage, databases, messaging, networking, and management tools available. And depending upon the requirement, we can choose any of the services, and then we have multiple resource, multiple configuration that we can choose from, and then we can choose to deploy our services one by one. Now, first of all, let's understand now, before we see the Azure dashboard, let's first of all understand what exactly DevOps is, so that we can start discussing on the implementation of, or we can say the structure of DevOps on top of cloud computing platforms. So DevOps, as we know, is basically the combination of development and operations activity that we have to take care of. So DevOps has multiple components inside it, like we have that basically we start with the building phase and coding plan. Now we have coding, then we have building, testing, releasing, deployment, operation, and then we have monitoring phase. A simple use case is where now we are going to discuss this part in detail as well. Let's say when we start working on the code here, we have multiple teams who are sitting in remote places. Therefore, suppose if we have a team sitting in Tokyo, other teams sitting in Mumbai, other teams sitting in, let's suppose, in North Virginia, right? So we have different teams coming in, and they all are contributing. They all are working on the same application, so they can all submit the code to a centralized code repository, and then we can connect that code repository like we have GitHub. Then we can connect that, and then we can have the entire code be prepared for a build. When we say build, then we can use tools like we have. So for coding and for source code management, we can use the tools like we have Git and GitHub. Whereas for building tools, for building the tools that we have discussed, again, for building, we have tools like we have Mavens, we have Gradle that we can choose from. And then we can choose any of the platforms. For example, we have Java application. We can choose Java application. We can create a build out of Java from the event library for Mavens, Gradle, depending upon the requirement. And then we can add testing script to it. And then once we have the entire code built, then we can simply create a test script out of it. For example, here for testing, we can use tools like we have Selenium. So we can use Selenium to create a simple testing component. For example, let's say we have a website. We have a website, and now we want to test multiple components of that particular website. So we can, for testing purposes, obviously we want the testing to be done through scripts. If we do not plan to use, or we can choose the manual testing, correct? So we can choose multiple scripts here using Selenium, and then using Selenium we can attach those scripts to the application build that has been created by Maven and Gradle, and then using Jenkins, which is now we can simply send it to the production, or we can say production testing or staging environment, where we can use tools for the continuous integration. We can use tools like we have Jenkins, which is the most popular, we can say, continuous integration tool available. And then for deployment, we can use tools like we have Docker, where we can use Docker to create a container out of the application that will contain the application as well as the bins and libraries for it. And then we can, if we have a requirement of deploying the application in large cluster of servers, then we can use tools like we have Chef, Puppet, Ansible. So we can use these tools to pull, or we can say to put the updates or changes, whatever we need to apply on any server which is being a part of the large cluster. And then we have monitoring. So in monitoring, we can use tools like we have Nagios, where we can use Nagios to create a simple report, and then we can use Nagios to generate the report so that our team can visualize on top of it. That's how it is structured in the complete life cycle for DevOps. So here we have tools, like in here we have tools available, like we have the component of, now before virtualization, we have tools like we have Docker, which is the most popular tool for creating containers. Then we have, for managing the large cluster of Docker, we have tools like we have Kubernetes. We have Docker Swarm, or we can use Kubernetes as a much efficient tool here. And then for operation, we have tools like we have Chef, for Puppet. Now these are part of configuration management tools through which we, if any configuration changes needs to be done, then we can use tools like we have Chef, Ansible, and Puppet. And the main challenge faced by the developers and the operators is simply they are always trying to make sure that in the case of any kind of failures or codes not working, they are always trying to pinpoint the entire fault to each other. For example, let's understand this by a simple use case. Now, let's say developers, they have built a Java code, right? And this Java code they have been using JDK 1.8 for completing this entire Java code itself. And once the code was created, now they passed on the code to the developers team. And once the operations team, they try to execute this Java code at their end, they were not able to execute that because of an error, right? And then the operators, they complain to developers that they have given them a broken code. And developers, again, they recheck the code, everything was working fine. Why this entire crisis occur? Because the operators were there, they are running on Java 1.6 or 1.6 itself. So obviously when there is a difference in the version, obviously that is going to create a compatibility issue for the application in case that does matter. And that simply creates a civil war between developers and operators. And just to make sure that this entire gap is not present, that's why we use tools for DevOps, so that we can automate the entire task. We can let the others know about the dependency that they need, and then we can have the entire development deployed. So as we discussed, for the coding phase here, we have tools like we can use tools like we have Git, Jira, SVN, where Git is the most popular tool for the coding phase. Then for coding, we can also use Eclipse. We can also use IntelliJ as a part of code editor. Then once we have the code ready with us, then we can use these tools like we have Maven, Gradle, and Apache Ant for creating a build out of it. And then we have test. Again, test is basically used for Jenkins, jQuery, and Selenium. We can add a bunch of multiple testing scripts and then we can deploy. Or we can go ahead and choose a product. If we talk about the releasing phase here, again, we have tools like we have Jenkins. Jenkins being one of the most popular platform as a part of continuous integration, where we can use Jenkins to design the entire blueprint so that each and every process can be automated. And then for deployment part here, we have tools like we have Chef, Puppet, Ansible, where we can choose this for deploying among multiple instances. Same way for SaltStack and for New Blank. So again, there we have to configure. Okay, it is us. I think this is. That means again we have to update that. Okay, the entire code has been deployed in Docker. And if we have a requirement of making some configuration changes on n number of servers, then we can easily do that. And then at last we have monitoring, where we can see we have multiple tools out there. So we have Bamboo, Nagios, Splunk, Sensius, where we use Nagios, or we can say Nagios much more as compared to any other platforms. So these are now basically in DevOps, there are hundreds of tools available for each and every category. And again, it is not advisable or nor it is feasible to learn each and every tool, even in whatever tool we are seeing on the screen. Even if we are good enough with just one single tool, then we are good to go. That means suppose in coding phase, if we are good with Git, then we are good enough. In building, if we are good with Mavens, then it is enough. If in testing phase, if we are good with Selenium, we are good enough. In continuous release, we have tools, we are aware of Jenkins, we are good enough. In the entire deployment and operation phase, if we are good with Puppet or suppose or Ansible or any of the platforms, we are good enough. Same way for monitoring phase, if we are good with the knowledge of Nagios being the only monitoring platform, then we are good enough for becoming, or for we can say for starting into the DevOps roles. So we don't need to be familiar with each and every platform that is offered by DevOps. All right, so now let's discuss on the components of Azure DevOps. So in Azure Platform, we have multiple services that we are going to focus on how we can implement DevOps strategy on top of Azure Platform. So Azure has multiple components. The first thing is Azure Pipelines. Then we have Azure Boards, Azure Artifacts, Repos, and Test Plans. So first of all, if we talk about Boards, then Boards is basically a service for managing the work for the software projects. And Azure Board just does that. And it brings a rich set of capabilities, including native support for Scrum and Kanban, including dashboards and all the integrated reporting. And mainly there are 5 core features to Azure Boards. Like we can have work items, boards, backlogs, sprints, and dashboards. We can say a really good platform for the Scrum, for the Agile and Scrum team, for designing a complete structure for the solution. Where we can create a board item here, like for example, in board we can have multiple work items, like whatever items we are going to create, and who is responsible for creating and deploying these different items, and if there are any issues or if that is open, then if it has been resolved or not, right? Now, when we sign up on Azure, we can sign up for a free tier account. And again, Azure is a chargeable service, but Azure offers us a credit of $200 on sign up that we can exhaust within 1 month, right? And there are some selective services that we can use within limitation for an year as well. We can do that. All right. So once we have the account on Azure, we can simply click on sign in. In case we already have the account, we can use the link such as portal.azure.com. So before we do that, let's discuss on the components as well as we were discussing. So first of all, we have boards. So boards are basically used for creating, or we can say creating a complete task where we can create multiple tasks, we can assign it to multiple users, and then we can track the status of each and every task as well, right? Whereas where we can create multiple boards, we can have a complete visualization done so that we can keep a note of whatever our team members they have been doing, and we can define the entire workflow as well for the project that we are working on. And then we have in boards, we have backlogs. So backlogs simply help us keeping things in order of priority so that we can understand the relationship between the work. And then we have sprints. So sprints basically give us the ability to create increments of work for the team to accomplish together. So just if we are familiar with the sprint agile scrum technology, we can say system, then you must be familiar with this. And then we can create the entire dashboard through which we can analyze how many tasks are active and how many application models are ready for testing, how many have been completed, and we can see the entire graph by stories by state and different pipelines in progress. We can see the entire state as a part of visualization that we can achieve by using Azure Boards. Now, after we are done with boards here, next is we can go for Azure repositories. So just like we have code commit available in AWS, in case you all have been working on AWS, or if you may be familiar with something as GitHub. So same way we have Azure repositories. So basically it is a Git service which provides unlimited free private repositories with collaborative code reviews, advanced file management, code search, and branch policies to ensure high quality code available as a part of Azure repositories. So we can connect this one with our own repositories as well. Like if we have our open source repositories, then we can connect, and then we can have it used for defining the pipeline as well. That means any changes done in this repository will be automatically fetched from the code pipeline available in Azure, and a build out of it can be created and pushed forward. Then we have artifacts. So artifacts manages the dependencies used in our code base, and it provides an easy tool to ensure the immutability and performance of those components. When we talk about immutability, that means we can make sure that the components are not changed, their status, their configurations are not changed, and the performance again can be easily monitored and structured as well. And that's why it simply helps in production and consumption of artifacts. So now let's see how exactly these components are structured in our Azure platform. So for seeing how exactly it works, for getting into the entire portal, we can use portal.azure.com for getting a clarity on how exactly the services work here. Now, once we are in Azure platform, we can use a service. Here we can see the entire dashboard for Azure that we have. In order to get started, we can click on create a resource. Here we can see the list of all the resources available, which has been divided in multiple categories for blockchain, computation, containers, databases, developers, DevOps, identity, integration, IoT. We have different configurations available that we can choose from. Now, if you want to start with the component of Azure, then we can choose the service for, we can say we want to use with DevOps, right? So we have a category available for DevOps itself that we can choose from. So here we can click on DevOps, and we can see we have different components for DevOps project. So first of all, we have to start with DevOps project. We can click on Quick Start. So this will take us to the DevOps page where we can get started. So here we can maintain multiple projects. Now, if we want to start with the DevOps project, we can choose what kind of application we are going to run, or we can say what kind of project we are going to run here. We are going to run our .NET project, Node.js project, PHP, Java, Ruby, Go, Python, or static website, or we are simply using C itself. So we can choose any of the configuration that depends upon our own code that we are having the access to. For example, we have a simple Node.js application that we want to use. We can take the help of PHP or Node.js. We can use any of these components. For example, we have a Node.js environment. We have a PHP environment. We can choose PHP, click on next. Then we have to choose a version. We are going to use a simple PHP, or we are going to use the Laravel framework as well. So for this hands-on, let's focus on simple PHP, click on next. And here we can see the service. We can choose a Windows web app, or we can choose the web app for containers, and we can choose Linux web app. So basically we are choosing the environment, and or we can say the configuration, the configured instances or servers on which we want to deploy the application on. We can choose accordingly that we are going to configure exactly as per the requirements. So here, let's say we are going to deploy the app in Windows web app or Linux web app. We can choose a Linux web app for now. Click on next. Here we can define the project name. Let's suppose here we can name it as Edureka app. We can define the name of the app here. Then we can define the web app name, the location, where exactly we want to deploy this application in. For example, we want to deploy this in Southeast Asia. We can choose Southeast Asia. And then we have to click on done. And basically this is simply deploying the project again that we can configure from scratch. We can do that. So generally when we deploy any services here, we will be able to see the entire services being deployed. So as it says, it is initializing the current deployment as we speak. So now in the meantime, it gets deployed. Let me showcase you the other components. So once the entire application has been deployed, this is the app one that we are going to look at, where we are going to have the access to create boards, repositories, pipelines, test planes, and artifacts. So basically we are using pipeline. So just the same thing which is done by Jenkins, where we can create our own pipeline. we have the component available in DevOps project by the name of pipeline itself, correct? So first of all, let's say if we want to create multiple repositories, we can create the repositories just like we have code commit available in Azure in AWS. Same way we have repositories available here that we can make use of. So for example, if we want to get started, we can simply see the list of all the files, right? And again, if you want to simply start with the repository itself, where we can click on start repositories, where we can clone to a computer, we can push any existing repository from a command line, or we can import any repository that we already have the access to. We can choose accordingly. So for example, here we can create any repository like we had done. We have a repository created, and currently we can see the content available inside these repositories. If we want to clone the repositories here, we want to create a build out of it, we can easily do that. We can easily do that. Suppose let's say here we want to create a file itself. Just like in GitHub, we can also create a file. Let's suppose here we have a file by the name of, let's suppose, home.html. Suppose we have a file home.html, and now if we want to simply add content to it, we can define the content for it as well if we want. Let's do one thing. Let's simply create a simple static file with us. Like we have HTML, then we have head, then we can open up title. We can name it as welcome. We can close title itself. Then we can close head. We can open up body. In body, we can define everything in center. Then we can use a simple H1. Welcome to Edureka. We can close H1. And then we can use a simple H2. We are learning DevOps on Azure Platform. We can close it. We can close H2. We can close the sender tag, close the body, and then we can close HTML as well. Now, let's suppose here we want to commit this code here. We can simply click on commit. We can define the branch name that we want to commit, and then we can click on commit itself. Here we can see the entire code being committed, having the commit ID that we had defined here. And then let's suppose if we want to push this to any of the building tools here, we can easily build it as well. If you want to see the history, we want to compare the previous versions to see the exact changes that we have done, we can easily do it. All right, so now here we can see the entire repositories here. We can see the entire list of all the commits that we had that has been made. And again, what is the graph of the commits? Here we can see the list of all the push that has also been made, the branches available in this entire repository. If you want to create a new branch for maintaining featured and multiple bug fixes, then also we can create them. Same way, if we have multiple users coming in with multiple tags, we can define the tags for them as well. We can do that. Next, we have pipeline. So pipeline is basically like a sequence steps. We can say a sequential step. For example, when we say we are creating a pipeline, that means, let's say we have a new code available in our source code repository, right? So again, for example, if we have new code available in our Git, then we can automatically define a new build should be created out of the code that has been pushed into the, we can say, a GitHub repository. And once that code has been pushed, then a new build automatically should be created by using Maven, Gradle, or whatever tool we want to use. Then we can decide, okay, if we want to test it, then we can attach a testing script as well. And then if you want, we can deploy it on production staging or deployment environment. We can do that. Correct. So again, either we can perform these operations manually one by one, or we can create a complete pipeline and then we can automate each and every process. That means as soon as a new code is available in the GitHub repository, it will be automatically fetched from the pipeline, and then a new build out of it will be created. A new testing script will be added to the build, and then it is going to be deployed on the servers as a part of pipeline. For example, okay, so let's say we are going to create a complete pipeline. Let's say we want that we are using, let's suppose we are using a GitHub repository and this repository has been connected by to multiple developers. Like we have developer 1, developer 2, and then we have developer 3. Kindly excuse for this beautiful calligraphy, guys. That's what happens when you try to write using a mouse pointers. So let's say we have multiple developers. Now developer 1 has pushed a new code. Developer 1 has pushed a new code. Now we want that whenever this new code is available in this repository, this new code should automatically be fetched and a build out of it should be created. For example, if this is a Java code, right? So and automatically a build using Maven or Gradle will be created. And once this new build is available, then if we want to test it, then we can add the testing script as well that we may have developed using Selenium. And then we can choose if we want to deploy this in multiple environments. For example, we want to deploy this in staging, production, or the testing environment, then we can deploy it automatically. And whatever the feedback is, that feedback can also be sent back to the developers for making the changes. So either we can perform these activities manually one by one, or we can create a complete pipeline so that we can automate the entire process, so that as soon as any new code is present, the entire process will be executed, or we can schedule the entire process as well. It can be event based or it can be schedule based as well. So you can define if you want to create this, if you want to run this to these steps manually, or we can automate it. And then we can define the pipeline. Suppose if you want to start by creating a pipeline, we can choose first of all where we have the code available with us, whether we have a code available in our GitHub or whether we are using the Azure repository kit. For example, we have the code available in the GitHub itself, not in our Azure repositories. For example, let's say we have a GitHub code available in our GitHub, then we can link GitHub as well. For example, let's say we choose a sample Java application available in GitHub. Let's pull one of the repositories. Let's suppose here we have a simple repository, right? We can copy the repository URL here that we can use back in our pipeline. So let's say here we want to use this GitHub URL. We can choose GitHub as our source. Then we can connect by logging in. Let's refresh. Okay, not a problem. So here we can use the Azure repository that we already have. So in the meantime, we can use Azure repository where we already have the sample HTML code available. So here we can use a startup pipeline where we can have the list of all the codes available, where we can define the entire pipeline that we have created, that we can here we can define the trigger, the pool, the steps as in the script. We are going to now in terms of script, we are going to echo hello world and display name as a run of one-line script itself, right? So whatever we want to execute, we have to create a simple YAML pipeline script. We have to define a complete YAML pipeline script, and then once we are done, we can click on save and run. Let's execute the sample script so that you can be aware of how the script has been created. So once the script has been created, now here the entire job is going to be queued. And then we can simply find the entire progress report for each and every plan that we have executed. We can, if you want to have multiple pipelines defined here, we can create the entire environment as well. All right, so I guess it's almost time now. So let's say we wrap it up for today, guys. So thank you so much for joining and have a great day ahead. Take care. Bye-bye.